Hi, good morning, all of you. So let's start our lean system chapter. We have already discussed about lean system in last session, and today we will cover this topic, total productive maintenance. We will cover this topic from lean system. If you remember in last session, we have covered about just-in-time system. We have covered about the lean management. We have covered about Kaizen costing. We have learned these topics in last session. So let's quickly revise what we have studied in last session, and let's practice some MCQ question from last session. So let's quickly revise. We have studied about the lean system in last session. We have learned about it. And we have learned lean means what? Identify the non-value added activity. Non-value added activity means we have learned that an organization can have 7 deadly waste. And we try to identify all those 7 deadly waste in the company, and we always try to remove them from the organization. So this is what we do in lean system. All right. And once once your organization is focused on removing these non-value added activity, what will happen? Ultimately, it will be focused on the value added activity. All right, see, this is something which we have already studied in value chain analysis also. Porter's 5 forces model is also focused on this, identifying the value-added activity and identifying the non-value-added activity and removing the non-value-added activity from the organization. We have studied all these things. We have learned all these things in our chapter 1. And you can see we are repeating the same thing again and again. We have studied the same thing in chapter 1, then we have studied the same thing in chapter 2. So you can see we are actually repeating, right? We are actually repeating the same thing again and again, right? So it is all the same, right? Okay. So we have studied value chain analysis, then we have studied in we have studied lean management. And in lean management, what we have studied, that organization should focus on improving the entire procedure of the organization, right? Organization should focus on improving the entire procedure of the organization. All right. So the way we are producing the product is important. The way we are doing the production is important. So the focus is on improving the entire procedure of the organization. Okay, then we have studied about the just-in-time system, and we have learned about the cellular manufacturing. We have learned about cellular manufacturing. Okay, what we have studied in cellular manufacturing? So we have studied that in case of cellular manufacturing or just-in-time system, we buy the product when there is requirement. Okay. We have learned 9 conditions of just-in-time system, in which one of the condition is that we will purchase the raw material only when there is demand. If there is no demand, we will not buy the raw material, right? So we will buy the raw material and then we will produce the finished good, right? So we will buy the raw material only when there is demand. If there is no demand, we will not buy the raw material. Then what will happen in case of just-in-time system and in cellular manufacturing, what will happen? We will produce the goods one by one, right? So this is also very important. In case of cellular manufacturing, we produce the goods in one by one. We do not produce the goods in batches. So here what will happen? We will produce whatever the raw material you will add here. First, this person with this working cell will add value to the product. Then this product will move here. Then what will happen? A person is sitting here. He will use these machines. Then with the use of these machines, he will add value to this product. Then what will happen? This product will move here. Then a person who is sitting here, he will use all these machines. with the use of all these machines, he will add value to this product. Then what will happen? This product will move here. Then a person who is sitting here will use all these machines, and with the use of these machines, he will add value to this product. Then this product will move here, and a person who is sitting here will use these machines, and he will add value to the product, and finally you will get a final product. So this is how cellular manufacturing, this is how in case of cellular manufacturing we produce the goods. And remember one more thing here, in this case, see, we have learned about what, that we will make grouping of machine, right? Grouping of machine. And what we have learned, we will, here it will work on Kanban system. So Kanban system means on one side information will flow, and on other side material will flow. So you can see finished good, here we have the customer, and here we have the supplier. So we will first receive the order from the customer. Right? We will first receive the order from the customer. Always remember, just-in-time system work on pull processing system. So first we receive the demand, then we will produce the goods, right? So what will happen? First we will receive the demand from the customer, right? Then what will happen? The person or the manager or whatever is present here, he will inform this person that we need the product. He will inform here that we need the product, your output. He will inform here that we need your output, and he will inform here, this working cell, we need your output, and this will inform the supplier, we need your output. So you can see on one side information is flowing. On one side here information is flowing. And once you will inform the supplier that we need the raw material. So you can see information is flowing on one side, right? You will inform the supplier that we need the raw material. What will happen? Raw material will straight drop the raw material on the production floor on the machine. Just remember, in just-in-time system, he will not drop the raw material on factory gate. He will drop the raw material on the production floor, on the specific machine where the raw material is required, right? So here what will happen, he will drop the material here, then the output of this material will move here, then the output of this material will move here, then the output of this material will move here, then the output of this material will move here, and finally you will get a final product. So in this way, on one side the information will flow, and on other side the material will flow. On the other side, the material will flow, right? And if you will observe here, I mean, such a smart strategy. It is such a smart strategy. By using this strategy, you will manage to reduce all 7 deadly waste from the company. All 7 deadly waste. So this will help the company to remove all possible 7 deadly waste from the company. So what are these? Like, first we have studied about the motion. So you can see, since now the worker are not moving here, here material is moving, right? So you have avoided unnecessary movement of employee or labor, right? This is avoided here. Now labor is not moving, because see, when the labor unnecessary move in the factory, what will happen? It will result in non-value-added activity. Why? Because once the labor will move, what will happen? Unnecessary, he is wasting his time. Because factory is very big in size, right? One machine is here, second machine is here, and unnecessary labor is moving in the organization. This will result in loss, right? It will be a non-value-added activity. So you can see motion, you can avoid this non-value-added activity can be avoided here, because you can see now the place of the labor in the factory is fixed. They are fixed in their place. They're working in only their working cell. That's it. They're just working on their working cell. They're not moving in the factory unnecessary. So motion have been avoided. Second, inventory. So you can see, since it is working on pull processing system, neither there is accumulation of raw material, nor there is accumulation of final good, nor you will find anywhere any work in progress, since it is working on cellular manufacturing. So no accumulation of raw material, No accumulation of final good, not even the accumulation of work in progress. Okay. So there is no accumulation of inventory, right? So you are avoiding this also. This is also a waste, right? Then we have learned about what? Transportation. This is also a waste. Transportation means unnecessary movement of inventory within the warehouse. So since there is no warehouse, it is working on just-in-time system. When there is requirement, then only we are buying the product. Otherwise, we are not buying the product. So for that reason, you can see inventory is not at all unnecessary moving in warehouse. There is no warehouse actually. And you know what? In fact, the raw material is dropped by the supplier straight on the production floor. How smart, right? So you are even avoiding the transportation, movement of inventory, right? So you manage to save these costs. What else? We have learned 7 deadly ways, right? Okay. So there is no overproduction. You can see fourth, overproduction. So since we are producing the goods on pull processing system, pull means when there is demand, then only we will produce the goods. Unnecessary, we will not produce the goods. So for that reason, when you will receive the demand, then only you are producing the goods. So for that reason, what will happen? Supply will always be equal to demand. So there will not be any condition where supply is more than demand. So there is no overproduction. See, when do we have the overproduction? When you are supplying more goods than the actual demand in the market. So then in that case, we will have the overproduction. So you can see here, there is no overproduction and supply is always equals to demand here. All right. So you are avoiding overproduction here also, right? And there is no rework. Why there is no rework? Because there is no defect in the company, right? So you can see, since they are producing the goods on cellular manufacturing, matlab one by one, you are producing the product. You're not producing the goods in batches. You're producing here the goods on cellular manufacturing. So cellular manufacturing means one by one. So you can see here, worker is focused on one product. He's observing each and every product, that 200 times. You can see first this person will watch the product, then this will watch the product, then this will watch the product, then this person will watch the product, then this person will watch the product. Point is that the same product is passing through eyes of each and every labor. The same labor is, observing each and every product, that too many times. There is no chance of even a single defect here for this reason, right? For this reason, there is not even single chance of defect, because one product is passed through by each and every worker, right? Here, worker will first check the product and do the value addition. Then the product will pass through here. This will check the product and do the value addition. So what will be happening? Actually, they are producing quality product, right, the first time. I mean, they are not at all, there is not even a chance of producing one defective unit. Such a beautiful way of producing the goods. You can imagine, not even one defective units they are producing. All right. So in this way, they have avoided the defects and rework. All right. What else? What else? What else? Not even a single defective units we are producing. All right. What else? We have studied about okay, so we have learned about that. We have avoided transportation using just-in-time system. We have avoided inventory due to just-in-time system. We have avoided motion due to just-in-time system. We have avoided defect due to just-in-time system. We have avoided overproduction due to just-in-time system. Now, yes, we can avoid the waiting time and overprocessing also due to just-in-time system. So waiting time is avoided here. How we are avoiding the waiting time? Because we are producing the goods in one by one, right? One by one means cellular manufacturing. So in cell, we are producing the goods. We are not producing the goods in batches. So since we are producing the goods one by one, all right, so what will happen? We are not producing here the goods on batches. So what will happen here? You are avoiding what? Waiting time. Worker don't have to wait, right? They'll keep producing the goods in this way, right? They're not at all waiting that when they will receive the product, then only they will produce the goods. So this is not happening actually, right? So here, no waiting will be happen here. Okay, no waiting. And what else? The last one is what? Over processing. So any other non-value added activity, they focus on removing any other non-value added activity also. So in this way, you can see such a smart strategy they have developed. We have learned this in last session. Our entire last session was based on this. Such a smart business strategy they have developed. All right. So with the help of just-in-time system, they have avoided 7 deadly wastage. And you can see they have adopted all W. Edward Deming 14 principle here. They have adopted Kaizen costing here. Kaizen means continuous improvement. So we have learned this in last session about what Kaizen costing we have learned. We have learned about Kaizen in last session, which is known as continuous improvement. And what is the meaning of continuous improvement? It means what? Kaizen means continuous improvement. That means improving your organization continuously, and it is everyone's responsibility. Everyone's responsibility everywhere and every day. Every day. So it is the responsibility of everyone in the organization to improve the entire organization every day and everyone. So we have learned that no organization is perfect organization. No organization. And there is always a scope of improvement for every organization. And everyone should keep on finding such scope of improvement every day and everywhere within the organization. So continuously focusing on improving the organization, and it's a never-ending task. It's a never-ending task. So this is Kaizen costing we have learned in last session. This is Kaizen costing. Improving the organization is Kaizen. Right, and actually Kaizen was adopted in Toyota company. See, everything, all these things were first developed in Toyota company. So Tahishi Ahono was a mechanical engineer who took this, who adopted what PDCA cycle. So you remember PDCA cycle was given by W. Edward Deming. Continuous improvement, PDCA cycle, that was given by W. Edward Deming, but it was adopted by Toyota company's mechanical engineer, Tahishi Ahono. He adopted it and he implemented the PDCA cycle of W. Edward Deming as a Kaizen, right? So this is what we have learned in last session. And then we have learned about 5S methodology also. If you remember, sort, series, sit on. First, we will remove all the unnecessary things from the organization. We have learned this, right, in last session, 5S methodology. Why I'm revising everything? For a reason, because I'll use all those strategies in today's session, right? And we will cover some questions also. So if you will see, we have learned 5S methodology. So if you will see, this is actually focus on organizing your workplace. Right? Organize. Your organization should not be cluttered, dirty, clumsy. Your organization cluttered, dirty, or clumsy. So your organization should always be organized. Your organization should always be properly organized. Okay, we do not want cluttered, clumsy organization. So what we have to do, Siri, Siton, Siso, Sikitsu, and Shitsuchiku, whatever. These are actually Japanese word, right? These are Japanese word. And the English conversion of these Japanese word is sort, means remove all the unnecessary product from the organization. Like I give the example, if there is any file which is not required again, right, that file I delete immediately, right? So you remove all the things which is not at all needed in the organization. Okay, so this is how we do the work. If we have any file which is not required, we just delete it. For example, you have a phone, right? You click some picture and you don't like the picture, so you immediately delete it. There is no point of keeping those pictures. So the point is that remove from the workplace what you do not need it and keep what you need it, right? This was sort. Set in order. Okay, now you have only those things which is required in the organization. Actually, if you will see here, we have hot site and cold site. Keep those objects near you which is required regularly, and keep those objects away from you which is not required regularly. So in this way, you will set in order which item should be placed where. So for example, I need laptop every day, I need computer every day, I need camera for every day. So the things which is required every day, I keep near me, and if there is something I need once in a while, I keep them away from me. So in this way, you have to find the place for everything in the organization. Then regular cleaning. So do not depend upon the maid or the peon of the company. Okay? Cleaning should be your own responsibility. Okay, so whatever you have sorted the thing, then you have set in order. Now you have to clean the places, right? Clean the desktop. It is the responsibility of the worker, those who are working there, not the responsibility of any cleaning house or peon or maid. No, it is not their responsibility. So when you are sitting in your desk, first clean your desk. If if you're a student also, right? Do not put your responsibility on others. It's actually your responsibility. Clean your place. Okay? Shine, simply shine without any excuse. Okay? Because if you will regularly clean, obviously you will identify everything which is not required. If you will clean your place, you will immediately find anything which is not required, and you can remove them, and you can keep only the things which is required in the organization. So we have learned these are the steps. Then we will make the standard to be maintained in the organization. We follow them and we sustain it so that our organization should always remain organized, right? We always want an organized workplace. We always want an organized workplace. Okay, so this is what we have learned in last session, 5S methodology. Okay, now today what we will do, let's do some question on it first. And then what will we do? We will solve total productive maintenance today. All right, we will do total productive maintenance. Let's do the question first. I hope it is all clear to all of you. If you have any doubt, you can ask me. This is the first question. I want all of you to read this question first. All right, read this question. I'll give you 2 minutes. Read it. Read this question, then I'll help you to read, understand. But let's first you people read this question. Okay, so I hope you have done the reading. So let's read the question together now. Mr. Rakesh is a newly appointed managing director of a company. So there is a company, and in this company, a newly appointed managing director. So there is a newly appointed managing director. All right, newly appointed managing director. He is not satisfied with the performance of the company. So in order to reduce the cost, improve inventory cost, and to improve services, okay, he is not satisfied with the company, okay, the way the company is producing the goods. So he want to reduce the cost, he want to improve the inventory cost, and he want to improve the services. Okay. So what he has done, Mr. Rakesh, along with the consent of costing department, has undertaken a decision to implement just-in-time system. So what is happening? This new managing director wants to implement just-in-time here. Okay. So obviously he will improve the entire procedure, because you know that in case of lean system, if you want to implement lean system, you have to improve the entire procedure of the company. The way the company is producing the goods, the way you will buy the raw material from the customer, right? Kanban system, regular working cell. So you can see, if managing director Rakesh, if Rakesh want to implement just-in-time system, he has to improve the entire procedure of the company. He has to improve the entire process of the company. Okay, now what is mentioned, the production management of mass is satisfied with the benefit of their changes, while supplies department is worried about, have a doubt. So obviously the company have what? The company have the production department. The company have supply department. The company have cost department also. So production department is happy. Okay, it is good if you will implement the just-in-time system, but actually supply department have a doubt regarding implementation of just-in-time system. They have a doubt. What doubt they have? We are dealing, see what they have mentioned you here. They have mentioned that we are dealing with the supplier for many years. They know their supplier. Actually, supply department, they knows their nature of their supplier. If you remember, I told you in just-in-time system, it is very important to maintain good relationship with supplier. I told you this is something very important, good relationship with the supplier. So here what is mentioned, that supplier department is worried about implementation of just-in-time system. And they have a doubt about it. What doubt? They argued that we are dealing with the supplier for many years. They would insist that we could only purchase in 1,000. What is mentioned? That here they will insist to buy the inventory in bulk. Okay. Supplier is not willing to supply the material, wherever there is a requirement. The supplier will always supply the material in, bulk, thousands of units together. That we would have to wait for every second week, month, and for that, they would only deliver on Saturday. Point is that they deliver the material every second week, that too on Saturday. Okay. But we have learned this in just-in-time system, that the supplier should drop the inventory on the exact time and date. Right? So the point is that in case of just-in-time system, we do not buy the inventory and we do not keep them in warehouse, right? And here what is happening, supplier is not willing to supply you the material when there is demand. He will not supply the material when there is demand. He is saying, see, I can sell you the unit in bulk, le jao, and then store it in warehouse and use it whenever it is required by you. So this is how supplier is willing to supply the raw material. But if you want to implement just-in-time system, then in that case, You keep on calling the supplier. Yes, supplier, we need this material. Yes, we need this material. We need this material. So in this way, in case of just-in-time system, supplier will drop the material straight on the production floor and on machine whenever there is requirement. Otherwise, he will not drop it. Okay. So the point is that according to supply division, they have a view it is not possible. It is not possible to implement just-in-time system. Okay. It is not possible to implement just-in-time system. This is what supplier department is arguing, right? Not possible. While production department wants to implement just-in-time system. Now, this is the question. This is the question, right? Now, what is the requirement of the question? Is Mr. Rakesh viewpoint is correct? Means, is it possible to implement just-in-time system? Now you people can answer. Is it possible in this scenario where supplier is only willing to supply the material in bulk? He is not willing to supply you the material whenever there is requirement. He will supply only on Saturday. He will not supply on exact time and date whenever there is requirement. So what do you think? Is it possible in this case to implement just-in-time system? Yes, tell me. Is it possible to implement just-in-time system in this case? No, because we have learned 9 conditions of just-in-time system. It is not satisfying here, right? So not at all possible to implement just-in-time system here, right? So just-in-time inventory system, what make frequent delivery on exact time and date. We need the delivery of material on exact time and date. We need frequent delivery. So not possible to implement just-in-time system. Next is what? And supply of the product on exact quantity as required. So we do not want the quantity in thousands. We only want the quantity as much as required. So we will buy the quantity as much as it is required. As much as there is requirement. We do not buy the inventory in bulk, and we do not keep them in bulk in anywhere in the company if it is just-in-time system. So it is not possible to implement just-in-time system here in this case. All right. Okay. Okay. Again, this is a next question and a very interesting question. So I am taking the second one first. Okay, this is the question. So what is happening? Caliber Meter and Motor Worker deal on manufacturing. What? They deal in manufacturing of the corporate wired electronic motors. So they are actually manufacturing motors here, which is specifically designed. Okay? The company is thinking to shift from traditional to just-in-time system. Again, here what is happening there, this is the goods they are manufacturing. Okay? And they want to shift from traditional system to what? They want to shift from traditional to just-in-time system. Okay, let's see. Is it possible for us to implement just-in-time system? Let's see. Okay. So CEO among the other bosses of this company hopeful that the implementation of just-in-time will not only improve the value in value chain for end consumer. So they believe that just-in-time will create value to the customer and it will help in removing non-value-added activity. That's true. We have learned this, that just-in-time system helps in removing all the non-value-added activity from the company. That's completely true. So what is mentioned here, they have mentioned that just-in-time system will help in creating the value, and obviously it will help you to remove the non-value-added activity from the company. Okay, but also improve the overall manufacturing cycle efficiency. So this will help in improving the organization. This will help in improving the overall manufacturing cycle of the company. Just-in-time system pre-implementation team was informed to evaluate the probabilities, which collect the following actual and estimated data about the process. Okay. So in case of normal traditional system, what is happening? Inspection is 45. For 45 minutes, we have to do the inspection. In case of traditional system, 80 minutes will be used in storage. 25 minutes will be used in moving the inventory. 70 minutes will be used in processing the inventory. So this is how the time is taken. While in case of just-in-time system, what is happening? Obviously, the inspection time will reduce. The storage time will reduce here. The moving time will reduce here. And the processing time will also reduce here. Okay. So all these things have reduced here. Now what will happen further? The company decided to practice single piece flow. Obviously, in just-in-time system, you know that we do not produce the goods in batches. This is generally, this is cellular manufacturing. Cellular matlab one by one, in cell, one by one, one by one. Using the cell, you will produce the goods one by one, right? So this is not the production in bulk, right? This company receive an order which is due to manufacture and delivery of 10 such motor. Total available production time to produce what consumer demand is 490 minutes. So total time is what? 490, out of which the normal practice that 40 minutes will spend on shutdown and cleaning. So total time is what? 490 minutes. Out of it, 40 minutes is shutdown. This is shutdown time. Okay, we'll spend on shutdown cleaning. CEO is also considering just-in-time purchase apart from production. Okay, so they want to implement just-in-time in production as well as in purchases. Advise whether the company should shift to just-in-time system. Yes, tell me. Is it okay to implement just-in-time system here? Tell me in comment. Tell me, is it possible to implement just-in-time system? Yes. Tell me, is it okay to implement just-in-time system here? Yes. So if you will see, total time is what? Total time for the production is what? Sum of these values, right? Sum of these values is the total time for production. Okay, let's see what is the total time of production. So 45 plus 80 plus 25 plus 70. This is the total time of production. Similarly, here what is happening? 30 plus 20 plus 10 plus 50. This is the total time of production. है ना? अब देखो, total time of production include both value added and non-value added activity. It include both value added and non-value added activity. It includes both. है ना? अच्छा. Now see what is their efficiency of production. Is it efficient or what? है ना? Let's see the efficiency of production. So what is the efficiency of production? You can see. First, see what is the value added activity. Total time is given, value added activity. So out of this, you can see what are the value added activity. Inspection is non-value added activity. We have learned inspection is actually, it is not 7 deadly waste, but it is it is actually a waste which is required in the company. It's not a deadly waste. It is a waste which is required in the company for reason, maybe the requirement of law, maybe the requirement of company. So actually this is a waste, but it is required in the company. Inspection, it's a waste. Okay? Storage is a waste, non-value-added activity. Unnecessary moving the inventory is a waste. So these are all waste activity. Obviously the process time is not a waste, right? Process time is the time you are taking to produce the goods. It is not a waste. Okay? So you know your value added activity here, 70 is the value added activity. Here 70 is the value added activity, and here 50 is the value added activity. Divided by total time is 220, and the total time is 110. This will give you process efficiency. If you can find and tell me the value here. Yeah. 31.82%. First one is 31.82%. And what is the second one? Please solve it and tell me the value. Yes, please solve it and tell me what is it coming. Tell me, please. Okay. So you can see out of these two options, the second one is efficient, more efficient. Efficiency is more, here you can see the value added activities are more as compared to total activity. This is more efficient. So yes, it is good to implement just-in-time system. All right, you can answer, yes, it is good to implement just-in-time system here. All right, it's good to implement just-in-time system here. Okay, so these questions will take time. I think I should cover the next topic first. If we will have time, we will come back to these questions and we will solve them. Okay, let's do the next topic now. So the next topic is what? Total productive maintenance, right? This is a new topic for us, total productive maintenance. Let's learn about it. Let's learn about the total productive maintenance. What is it, ma'am? It's a new topic, right? We have learned about the just-in-time system and a lean system. This is completely a new topic, total productive. So till now, we have learned about just-in-time system. We know the importance of implementation of just-in-time system. We have learned about the just-in-time system. We have learned the importance of just-in-time system, right? Okay. We have learned about the just-in-time system. You can imagine that if you will see just-in-time and lean system, so you will see that entire concept of lean or just-in-time system is focused on improving the process of the company. It was all focused on improving the process of the company and the procedure of the company and the way we produce the goods. It was all focused on that. And we have just discussed that in case of just-in-time system, we will do what? Grouping of cell. Grouping of cell. Sorry, grouping of machine. In case of just-in-time system, product will move, and one person will stand on a place. People are not moving, machines are not moving. Only the material will move in one line, and these workers will keep adding the value on it. This is what we have learned. So if you will see here, worker have been appointed. We have appointed these worker, group of machine, M1. So we have given them group of machine on which they are using actually these group of machine to add value to their product. Right? These are group of machines. They are using these machines to add value to the product. Right? They're using these machines to add value to the product. Now the point is that, see, here, I told you this in last session also, here we are actually increasing the responsibility of these labor. They are just labor, right? But actually we are increasing the responsibility. How? First, they are checking, I mean, when they are producing the goods, they are they have an eye over the product. They're actually observing the material, how they are producing it. So each and every material, they are observing it carefully while they are producing it. So for that reason, there is no defect in the company. They are observing the material. They're actually observing the material. And second thing is what? They're actually observing the material. Second is that one person is maintaining multiple machines. Ab dekho, here what will happen? His responsibility to maintain the machine will also come. To maintain machines. So here what will happen? You will give them responsibility. One person, this one person has to maintain multiple machines. So his responsibility to maintain each and every machine will come here. He has to keep maintaining them. Ab dekho hota kya hai? What will happen? Agar in case, see here, this person A is using machine M1, M2, M3, M4. Then this person is using machine M5, M6. Then M7, M8, M9, M10. Here M11, M12. M12. Okay. And raw material is coming here. It will keep on moving to get the value addition, and then you will get the final goods. Point is that if you will see here, what will happen if any of the machine fail here, for any reason, the machine stop working here, it will create disaster for entire value chain. Sorry, for entire cellular manufacturing or just in time. The process of manufacturing, right? The way you are producing the goods, if even a single machine will fail here, it will interrupt the entire process. See, this happen in traditional way also, right? When you are producing the goods in traditional way, this happened there also. When machine will get shut down, it get interrupted for any reason, breakdown of machine because light is not coming, or for any reason, if machine will break down, it will interrupt the entire production process. And what will happen then? The worker have to sit idle. They have to sit idle and they have to wait for the machine to work again. You can imagine it will be a waste for the company, and you can see a deadly waste, because if the machine will not work, worker will not work. If the worker will not work, obviously you are using all the resources. You are paying the rent, you're paying electricity bill, you're paying everything, but actually worker is not at all producing the goods. And though you are incurring the cost, but you are not producing the goods, it's a waste of resource in the company. I hope you can imagine how important it is for every machine to work properly. And it is not, any breakdown is actually not acceptable now. Breakdown of machine is not acceptable at all now. How important it is for the machine to work properly and without any interruption. How important it is for the machine to work without any interruption. I hope you can imagine why now we are talking about the machine. All right, so the point is that here it is all focused on what? Improving the machine's function. So now we are putting the responsibility on the labor to maintain these machines. You must have heard prevention is better than cure. So if the machine will break down, then you have engineer team here, a team of engineer, and those team of engineers will fix the defect. But why is it required? Why is it required? Why don't you keep your machine updated all the time? Keep it updated now. So, I mean, see, the point is that don't allow any breakdown of machine. What happened, for example, I'm just giving you an example. I'm taking your class. During the session, my camera is not working. Maybe for any reason, my laptop will not work. Maybe for any reason, the laptop is not working, internet is not working. So what is it? This is not acceptable. Why? Because it will interrupt the class. So the point is that why don't you check everything before starting your work, right? Check the internet, check the connections, check the laptop, check your all equipment. Point is that the one who is working with the equipment should be so well that he know that how the equipment is working. He will not allow any interruption, any breakdown, because breakdown is a waste actually, right? So actually you can see how important it is here, the relationship between this labor and machine. So actually this is actually a very special relationship, labor and machine. This relationship is also very important. Relationship between whom? Labor and machine. So actually we called it mother and baby relationship. We called this relationship as mother and baby relationship. So like mother take care of their babies so much, same way here we expect this labor to take care of these machines just like a mother take care of their baby. This labor should take care of these machines in that same way, so that there will be no breakdown. And a breakdown is, breakdown means interruption of entire workflow. I hope you can understand and imagine the scenario, how important it is. I hope you're understanding and you're imagining the scenario. All right. Okay. So if you will see here, what do we have? Total productive maintenance, right? Now, total means everyone in the organization is responsible for this. Productive means we do not expect any defect, no mistake. We do not expect any defect or mistake. We do not expect any breakdown of machine. We do not expect any breakdown of machine, and we do not expect any accident in the company. We do not expect any accident in the company. So no mistake is acceptable, no breakdown of machine is acceptable, and no accident is acceptable in the company, right? Zero defect, zero breakdown, and zero accident. Okay. And for that you have to maintain what? Plant and machinery. Okay. You have to maintain the entire process of the company. You have learned we maintain the process in just-in-time system. So if you don't want any mistake, we want just-in-time system. If we expect no mistake, no defect in the company, we want to implement just-in-time system. And if you don't expect any downtime of plant and machinery, so we expect no breakdown of machine, zero breakdown of machine, right? And production management system, the entire production management system should be proper. Okay. So the point is that you can see it is the responsibility of everyone in the organization, okay, to ensure. Actually, if you will see here, two things have been introduced. First, we need a good work process. We need a good working procedure. Now, second thing is that here the labor should be well equipped, well trained to maintain multiple machine, so that no accident of machine is allowed, no downtime of machine is allowed. So I hope you can imagine this scenario. Okay, so total productive maintenance helps in keeping all equipment in top working condition. मतलब देखो, you have the machines now. So obviously, you know, with time the machine will degrade, है ना? When we use any machine, obviously with time it degrade, right? But the point is that here it is mentioned that keep maintaining them. You will learn it in your this topic, how to keep maintaining the machine. What is the meaning of it? Always keep maintaining it. Keep maintaining means always properly clean the machine. The one who is working with the machine should always clean it. Grease the machine. Greasing of machine is important, right? Grease them. Then if there is any loose bolt, tight them. If you know that any breakdown could happen in future, immediately inform the engineering team to correct that or replace the machine. So the point is that this worker have to focus on all these things so that they can avoid any breakdown of machine, so that there will be no delay in entire manufacturing process, because only one machine, if one machine will fail to work, the entire process will get interrupted. Especially in just-in-time system. If one machine will fail, the entire process of production will be interrupted. So this is done through machine, equipment, process, employee that add value to the business. So we want to maintain the machine, we want to maintain the equipment, the entire process of production, and employees and labor is important for this, right? So all these will help. Tabhi to total, they are using the word total. It is not the responsibility of one person in the organization to maintain it. For that reason, we are using here the word total. All right. So I hope it is clear that why are we introducing it. Now, for the implementation of, just keep it in mind, total productive maintenance is not just focus on what, it is not just focus on, give me 1 minute. So it is not just focus on the process. It is not just focus on improving the process of the company. It is focused on improving both process as well as improving the machine of the company. Okay, allow me, just give me 1 minute, I'll share. So it will be focused on not just improving the process of the company. It is not just focused on improving the process of the company. Instead, it is focused on improving what? The machines of the company and the relationship between the machine and the worker. Right? So we need to improve both, right? We need to improve the entire process of the company, the way we are producing the goods, and we need to improve the machine of the company, right? We need to improve both. All right. Okay. So you can see total productive maintenance is based on both improving the procedures, process, and maintaining the machines also. Okay, this is the goal of total productive maintenance, right? Improve process, which you have learned in lean system or just-in-time system, and improve machines. We need both. We need to improve both. So what is the aim? Zero defect. We get the zero defect if it is just-in-time system, lean system, it is possible to achieve zero defect. Okay? Zero breakdown is possible if you maintain the machine. And you know, there are many chances of accident in the factory. You must have seen, I've seen in old movies, right? Old pictures. So all these machines in the factory are responsible for labor accidents. Sometimes, their hand, I have seen such accidents. So even while they were constructing the metro lines, one of doctor's clinic near the metro station, they were discussing. I have observed this, so I'm just sharing my experience. So they were discussing about all such accident, because generally they work on at night, and these doctors, they receive such cases at night, that labor, their hand got damaged or something, their legs got damaged during the construction of the metro. So the point is that when they're working in the factory, the chances of accidents are, huge. Labor accident when they are working with machines. So the point is that safety of the labor is very important. Now, I hope you can understand. So safety of labor is also very important. Right? So zero accident matlab what? No accident of the labor. Okay? Their safety. They're talking about their safety also. They're not just focusing on improving the process or the procedure. They're not just focused on maintaining the machine so that there will be no breakdown. And they're also focusing on zero accident. Zero accident means there is no accident of the labor, right? No accident of the labor. So actually they're focusing on all these points. Okay? अब देखो, for the implementation of total productive maintenance, the base is actually 5S methodology. You can see 5S methodology means organizing the things first. First, you have to organize everything in the company, right? The way you are producing the goods, the way you are buying the raw material, the way you are delivering the goods, everything, the entire procedure should be well organized. So you can see the entire base of this total productive maintenance is what? 5S methodology. Okay, see what is written here. Total productive maintenance strategy focuses on 8 pillars of success with 5S strategy foundation as foundation. So here you can see we have 8 pillars. 1 pillar, 2 pillar, 3 pillar, 4 pillar, 5, 6, 7, 8. So you can see these are 8 pillars, all right, and the foundation for these 8 pillars is 5S methodology, and the goal of these 8 pillars is that no defect, not even single defect, zero defect, no breakdown, not even single time the machine will fail. How beautiful, huh? Not even single time you're allowing your machine to fail. Zero breakdown, zero accident, not even a single accident of any worker or labor, not even single accident. Beautiful. They're focusing on everything. They're focusing on their employee. Humans are important, right? So the point is that they're focusing on everything. They're focusing on their way of producing the goods. They're focusing on their materials. They're focusing on their labor, everything. Okay. So these are what? Okay. So this is what total productive maintenance. Okay, so I want to take a break for a reason. I want to show you a video which I don't have here. Okay, give me 1 minute. Let me check it first. I will show you a video, also a very good video. But let me see first I have it or not. Okay, let's do one thing. Let's take a break of 10 minutes, then we will come back. Let's take a break. So hi, welcome back. So we have learned about total productive maintenance, and as I told you that I'll show you a video. So I have taken a video, right, related to total productive maintenance. We have learned about it. We have learned that we want to achieve what here we want to achieve. We want to achieve zero defects, no breakdown at all, not at all, right? And zero accident. We do not expect accident in the company. Life is important, right? So, and the base for is 5S methodology. You will see continuous improvement is also the base for it, right? And we will study about these pillars. It's just a 3-minute video. I expect all of you to watch this video. So they will maintain the detail of each and every machine here. They will maintain the history of each and machine here. They will keep looking how much maintenance is required, within what frequency the maintenance is required, how long it will take to maintain the machine. So they will all keep such maintain. So you can see total productive maintenance is focused on maintaining the machines. Plan maintenance, cleaning management. Cleaning is very important, as I told you. Regular cleaning is very important. That will help to detect the problem like this, right? So this is what we have studied here, that in case of total productive maintenance, it is all focused on machine maintenance, right? It's all focused on maintaining the machine. All right, so let's do this. So what is it? Maximize the equipment effectiveness. Matlab, equipment should work effectively, right? They're focusing on equipment efficiency. No breakdown, no defect at all, and no accident. And there should be no waste, no non-valuated activity at all in the company, right? Even if the machine will interrupt, there will be what if the machine will interrupt, what will happen? Obviously, that will result in waste in the company, which is not at all acceptable, right? So here what we are saying, machine maintenance is the responsibility of the person, those who are working there, right? So what was the old attitude? Old attitude was worker and engineer. They were different people, right? So if the machine will break down, they will inform the engineer will fix the problem. That was a lengthy process, right? So this was an old attitude. What I operate, the worker is operating, engineer will fix the problem if there will be any problem. I fix, you design, I design, you operate. So engineer is designing, worker is operating. This is an old attitude, right? Now, what is ATM, TPM attitude, total productive maintenance attitude? We are all responsible for our equipment. So maintaining the equipment is not the responsibility of only the engineers. Workers are equally important to maintain the machines, right? Here, what we have done, we have increased the responsibility of the worker, and we have mentioned that the workers are equally important to maintain the machine. Okay? So you can see, operator means worker here, those who are working, or the laborers, right? Obviously, operator use the plant and machinery, है ना? Worker use the plant and machinery. Engineers, they maintain the machine, right? So if there will be any problem in the machine, they will fix the problem. Engineer fix the problem. This was the old attitude. Now, what is the new attitude? Both of them, the worker and the engineer, they will keep maintaining the machines all the time so that there will not be any defect and they will not at all produce the defective units, right? So I will teach you about all these techniques. You can see it is all 7-8 pillar model. So first is you can see 5S methodology is mentioned here, and your continuous improvement is also mentioned here, and remaining we will learn. And just remember one more thing I forgot to mention you all about what 5S methodology. Then we will start, we will learn about it. So why in 5S methodology, if you will see, first is that we remove unnecessary thing, sort. In case of sorting, we remove the unnecessary thing. Then we organize the things, right? We set the orders, which product should be placed where, set in order, right? Then cleaning. Then third is cleaning. Now the point is that these steps is actually helping you to organize the workplace. Okay. Now the point is that they have used this standard and sustain. So all these 5S methodology is used to organize the workplace. And why are they using it? They're using it to organize the workplace with an aim that, see, the point is that when the place is clean, it is very easy to identify the problem like this. See, when the place is unclean, untidy, right, cluttered, dirty, clumsy. So when the place is cluttered, dirty, clumsy, if there will be any defect, error, it is not easy to identify them like this. And if there will be any defect, any problem, it is not possible to find them. But when the place is very clean and tidy, even a small error can be identified like this, because the place is actually clumsy and cluttered and dirty. So if the place is clumsy, cluttered, dirty, if there will be any defect, error, it is so easy, it is visible, actually aankhon ko chubhegi, right? If there will be any problem. So for that reason, they have first considered 5S methodology, the clean environment, organized environment, because in clean and organized environment, if there will be problem anywhere, it can be, you can identify them like this. Okay. So for that reason, for the implementation of total productive maintenance, they are first considering 5S methodology. So we have learned about the 5S methodology, that we will have these steps here: sort, set in order, standardize, and sustain. So sort means you will remove all the things which is not required. Then you will set everything. You will give a place to everything. Then you keep on cleaning that place, and then standardize, and then sustain it. 5S methodology, we have done it many times, so I'm not giving it more time. Okay. So you are just organizing the workplace. ठीक है, so that any hidden problem can be identified easily, right? This will help to identify any hidden problem. See, what is to recognize uncovered problem, right? A company or the company can have a manufacturing company can have, you know, any problem which is uncovered. So any problem, with the help of 5S methodology, it is possible to uncover such problem, identify such problems, right? So this is 5S methodology which is used here. Okay. Give me 1 minute. So now we will learn about these pillars. We will learn about these pillars now. So total productive maintenance strategy focus on 8 pillars of success. And the base is 5S methodology, right? 5S is the base. These are 8 pillars of total productive maintenance, right? These are 8 pillars of total productive maintenance. 5S methodology, first is that we will implement the 5S methodology in the company. So this 5S methodology, it all total productive maintenance, it all started with 5S methodology. So what will happen if your workplace will be organized, any hidden problem can be identified very easily. If there will be any hidden problem, you can identify them like this, right? And cleaning and organizing the workplace will help to recover any uncovered problem, hidden problem from the company, and making the problem visible in first step of the improvement. So we want to improve the organization, and for improving the organization, the problem is so visible now, right? If you implement the 5S methodology, problem will be so visible like this, right? So when the problem will be visible, you can identify it and you can easily improve them, right? Okay. Okay, give me 1 minute. So if you have any doubt, you can ask me your doubt also. If you have any doubt, if you're facing any doubt or problem, you can ask me your doubt. Okay. So first is what? Autonomous maintenance. Okay. What is the meaning of first pillar, autonomous maintenance here? So you can see what is happening. I only operate the machine. Any problem you fix. So generally what happened, operator and engineer, they divide their responsibility. है ना? Operator says, I can only work. I don't know how these machine works and how to fix the problem. So he just impose all the problem to the engineers. But now worker is actually taking the responsibility. Okay, I will fix any problem if it will arise in the company. So in case of autonomous maintenance, worker is actually taking the responsibility of the machine. It is now the responsibility of the operator to keep the machine in good condition, right? So operator of the equipment is responsible to maintain the machine, not the engineer, right? Actually, both are responsible, but now the responsibility of operator has increased. Earlier, operator imposed all the responsibility to engineers, but it's not now. Okay? So it is the responsibility of the operator to make the machine, maintain the machine so that it can work without any breakdown, eliminate the defects, okay, at the source through active employee participation. So they will eliminate any breakdown of machine. How is it possible? These operator keep on cleaning the machine. They are all engaged on cleaning the machines, right? They are all engaged in greasing the machine or lubricating the machine. You know, machine need regular greasing, right? In machine, if you want them to work properly, actually machines are all made of iron, right? So iron got rusted with time, and that reduces the efficiency of machine. Like two machines are working like this, right? So what will happen due to rusting, maybe their speed of work will slow. So what is required here? Greasing is required. For example, these two machines are working like this, so greasing between them is required so that they can work efficiently. So lubrication or greasing is required. Visual inspection. So worker, before starting the work, they keep on checking their machines. Visually, they will check, oh, is there any loose bolt? If there, for example, he will check if there is any loose bolt, he will just tight it, right? So keep on visual inspection and keep on finding if there is any problem in the machine, right? So this is the responsibility of whom? This is the responsibility of the worker, those who are working on the machine. All right. Okay. Okay. Next. So second one is what we have learned. You can see entire lean management is focused on Kaizen costing. So you can see here, this is also focused on Kaizen costing. Kaizen means continuous improving the organization. No organization should be considered as perfect organization. There is scope of improvement everywhere. Keep find it. It is responsibility of everyone, everywhere, every day to keep on improving the organization, right? So this entire pillar is focused on implementing the Kaizen costing also, right? Kaizen is also important here. Continuously improving the organization is also important here, right? So this is also important here. Kaizen costing is important here. So in case of Kaizen, you will keep identifying the scope of improvement. You may do the why analysis, summary loss, right? Summary sheet. We will consider all these things. Okay. Third is what? Planned maintenance. Now, what is planned maintenance? So what will happen? You will do here preventive maintenance, breakdown maintenance, corrective maintenance, and maintenance prevention. So as I told you, prevention is better than cure. So here the focus is more on preventions, right? Keep checking the machines. So it is the responsibility of the operator to keep on checking the machine. I told you that the relationship between the operator and machine should be like a mother and baby relationship. So how mother, they take care of their baby, similarly these operators should keep on taking care of the machines, right? It should be like mother and baby relationship. So the proper maintenance of the machine is required, right? And it is actually focused on what? Preventive maintenance. So that it will increase the reliability and maintainability of the equipment, plant and machinery. Right? And so that there will be no breakdown at all. No downtime. Third is early management. So what is early management? So this will be focused on what? Shortening the time required for product and equipment development, right? So I mean, it is actually focused on removing all the places where you are wasting the time, right? So for that we need re-engineering, right? Re-engineering will help you to identify all the places where we are wasting the time, or it will help you to remove all non-value added activity from the company. But yes, abhi re-engineering is not clear. I have not explained it. So you will understand the meaning of business process re-engineering later on. But yes, sometime business process re-engineering is also required here, right? Next is quality maintenance. As I told you, see here they are considering total quality management. You know? So what is total quality management? Producing the quality product right the first time. So how is it possible? Identify. Is there any root cause of problem? Do the why analysis, find the root cause of problem, remove them, analyze the customer data, and just see how you can provide the customer satisfaction, right? So this is all achieving the customer satisfaction by providing them high quality product. And how is it possible? We have learned that we can provide the quality product only when we have very good process or procedure of production. Our production process is in such a way there is no chance of any defect, not even a single defect is allowed here. No mistake, no defect is allowed here. So for that, do the root cause analysis. If there is any problem, do the root cause analysis or customer data analysis. Okay. After this, next is education and training. So as I told you, machines, operators relationship with the machine should be like mother and baby relationship. But the point is that labor are just labor, right? Maybe they don't have enough qualification as engineers have. So for engineer, they know all the mechanical engineer, they all know about the plant and machinery. They have all knowledge about the plant and machinery. But worker, they have not studied about the machines, right? But still we are expecting the worker to know everything about plant and machinery. Worker are not expert of machinery, right? But still we are expecting the worker to understand everything about the plant and machinery. So how is it possible? Provide them training now. Provide them training, right? So what we will expect here, we will provide them training. So education and training is also important here. Okay. So what is the purpose? So that these employees and worker or operator, they can work properly and they can fulfill the expectation. Our expectation is that they should know about the machine. Workers should know about the machine, right? So for that, you need to provide them training. The aim to improve knowledge and skill and enhance the morale of employee. So what will happen? Provide them training, provide them education wherever possible. On-site training. This is also very important here. Achha, next is office total productive maintenance. Okay. So what will happen if you will improve the entire process and procedure, it will improve the office work also, right? So every organization, factory is different, office is different, but this will help in improving the office of the organization also. Okay. So total productive maintenance technique is in administration to improve the productivity and efficiency in the function with elimination of losses. This will improve the office total productive maintenance also. And the last one, see, I told you that we want the safety of the people, those who are working in the organization. So as I told you that if you will remember W. Edward Deming principle, there we have learned no quotation is required. Do not put any quotation for the employee. Ab dekho, quotation is what? I remember when I was a student, very ambitious student. And when I was a student, so that was in my mind that yes, I have to clear my exam, CA exam. I know it's a difficult, right? It's difficult to clear CA final exam. So I remember I have put equal efforts to do it, right? So my room was full of books and my wall of the room was full of, quotations. So everywhere I put, on the wall, quotations, right? On my table, I put very good quotation for myself. on the wall, very good quotation. Now, if you will see, my wall is all empty, no quotation, right? So the point is that when I was a student, very focused, I want to clear my CA final exam, and quotation everywhere in my room. And those quotation that encourage me every day. When I wake up early morning, I read those quotation, and that quotation helped me, right? That yes, this is my aim. I keep on reminding myself that yes, this is my aim. I have to work hard. I have to achieve it, right? I have to become a chartered accountant. So this was a life of a student. I know you must have the same life. So the point is that quotation helps to encourage the people to work more. But in case of W. Edward Deming, we have learned, don't put such quotation for your employee. Give them freedom to work. Do not impose the work on them, right? This is what we have learned in case of W. Edward Deming. No quotation for employee. Matlab, no quotation that encourage them to work more. No, give them, allow them to work like a turtle. Slow and steady will win the race. Little by little, a little become a lot. So allow them to work slowly and steadily. This was W. Edward Deming philosophy. Do not give any quotation to them. But here, if you will see, it is written that give them a slogan, safety slogan. Don't give them quotations or slogan to work more, but safety slogan is important. You can see. So what is written here? Give them safety slogan. Safety is important. Everywhere where the workers or operator are working with machine, you know there are chances of accident. If you have seen in old movies, see, I'm elder than you, obviously. So I know, I have seen this in old movies that a person is working in a factory, his hand got, he got in accident, someone lost his hand, someone lost their legs. You can imagine if a person is already a laborer, right, and he lost his hand, how he will survive, how he will work, and how he will maintain his family. You can imagine how difficult it is for a family, right? So the point is that give them safety slogan, right? Accident is not acceptable in the company. Life of the labor is important, right? So you can see here, this pillar is focused on safety, health, and environment in the organization. So safety and health of the operator, those who are working on machines. Okay? So aware them with the help of a drama in the company, with the help of a drama, aware them about the safety, about their safety. Give them safety slogan. Okay? Make quizzes in the company so that they become aware about the safety, right? Make posters in the factory so that when they read, they should be aware, oh, we should not do this. Otherwise, we may lose our hand or leg or, our life. So give them safety slogan. Take a poster making to create awareness related to safety. This is important, right? Safety of worker is utmost importance. Okay? It aims to reduce the accident. And here we are expecting no accident at all. Not even one accident is acceptable. Zero accident, right? Zero health damage is what? The 8th pillar. You can imagine, I really like the way it's all developed here. These strategies have developed here. All right. Okay. Let me check. We have covered everything, by the way. Safety of the worker, right? We keep giving them slogans. We keep awareing them about, their safety. This is important. Okay, so these are the pillars. These are the pillars of what? Implementation of total productive maintenance in the organization. I hope it is all clear. Right? So what is the benefit of total productive maintenance? It increases the equipment uptime. Downtime will be reduced. Downtime will be reduced. No downtime. Equipment uptime will increase the capacity of plant and machinery. It lowered the maintenance and production cost, and it lowered the defect in the company. It lowers everything, right? Okay, now we have these points which we have to learn. All right, we have these points which we have to learn. What are these points? Performance measurement in total productive maintenance. how we can measure the performance in total productive maintenance. So what is written here? The calculation of OEE. We will calculate overall equipment effectiveness here. Okay. In total productive maintenance, we will now we are learning about overall equipment effectiveness. This is very important actually. So we actually calculate this in the organization. OEE, we calculate this for the organization. Okay. How effectively the equipment are working in the organization. And let me tell you, 100% operating efficiency is not possible to achieve for any organization anywhere in the world. 100% is not possible to achieve. Okay. अब देखो here, where are we focusing? If you will observe here, we are focusing on identifying. Here we are focusing on identifying the losses, right? So what is mentioned here, labor, plant and machinery, this type of losses is easy to identify. And it do not impact the organization much as compared to these losses, right? These losses have a high impact in the organization. Equipment failure, I told you now, when machine will fail, entire production will stop, right? So equipment failure or failure of production is not acceptable. Quality defect, you are producing defective unit and reworking on it to correct it is not acceptable, right? Reducing the speed of production, not acceptable. Okay, idling or minor stoppage, small stoppage, right? It will result in loss. Setup cost, machine setup cost. You know, before production, we have to do the machine setups, right? So you will check machine setup, is it acceptable or not, right? We will see, is it acceptable or not, right? So these are what, these will have high impact on the organization, these failure. We are learning this so that we can calculate OEE. So here we are learning that how we can calculate OEE, overall equipment efficiency, how we can calculate the overall equipment efficiency for the organization. All right. Okay. So I want to use my, give me 1 minute. So if you will see here, we are learning about overall equipment efficiency. So this actually depends on what this overall equipment efficiency is actually depends upon what availability. All right. It depends upon availability. So it depends upon availability, it depends upon performance, and it depends upon quality, right? So we are learning here about OEE, overall equipment efficiency, and overall equipment efficiency depends upon the availability, performance, and quality. Let's try to understand these three words. So you can see I have connected the losses with these three words. Huh? Availability, you can see availability, performance, and equipment. So I have just connected it with what? Availability, performance, and quality. These three words, right? We are learning here about the availability, performance, and quality, right? We are relating with this. Okay, so what will be happening here? You will see that we have this formula and we have to use this formula for solving the questions, right? Let me write it here. Availability, right, into performance, right, into quality. This will be equal to overall equipment efficiency. So yeah, I just want this. Okay, so I'm just relating it. You can see this is a formula you will use and you will find many questions on this formula in your LMS, right? You will see you will have many formula in your learning material, right? This formula, you have many questions in your learning material. Okay, so availability is related to what? Loss of time. How much time you are losing, right? Availability is what? How much time you are losing. Okay. Then performance is related to what speed you are producing the goods. If the speed will be slow, it will result in loss. If the speed will be fast, it will result in, quickly production of the good. And quality means if you produce defective units, right? Defective units, then it is related to quality. Okay. So overall equipment efficiency means you can imagine no defect, no downtime, machine failure, no health issues, right? No accident in the company. Okay, now if you will see, and this will be considered to conclude whether the company is efficient or not, right? Okay. So availability is related to what? Okay. Availability is related to what? Unplanned stoppage and planned stoppage. So planned stoppage means what? Planned stoppage. When you want to produce the goods, when you want to do the production, when you want to produce the goods, you have to spend some time on what? When you want to produce the goods, you have to spend some time on what? You will spend some time on what? Setup time. Whenever you want to produce the goods, before the production, we need to do the setup time. So no matter how good your organization is, you have to incur the setup time. Okay. So setup time and adjustment, we need to consider it. It will come under planned stop. This will come, right? This will definitely come, right? So this will be considered as planned stop. Okay. Unplanned stop means machine is working, but it got stopped. Why? Because of machine failure. So because of machine failure, the machine stopped working, right? Will be what? Equipment failure or unplanned stop. Okay. So you can see time loss. One time you will lose because you need time to set up the machine for the production. You need time to set up the machine for production. Because of that, you are losing your time. Second is that during the production, if the machine will fail, what will happen? That is your unplanned waste of time. That was not, you have not planned that. Okay, so the point is that you can minimize this. You cannot completely eliminate it, but this can be possible to eliminate, right? This is possible. Failure of machine can be, it is possible to eliminate them from the organization. Okay, let me show you something. Okay, so first we have learned about what? Downtime. So first is what? Setup time. Your organization will always have some setup time. They will always take some setup time. Breakdown means avoid the breakdown of machine, right? So we want to avoid it. You can minimize it, but we want to avoid it completely. Okay, what else? Okay, that's it. This one. So this is something I want to explain you. So plant operation time, the time period within which the plant will operate. Okay. So we can have planned production time and planned shutdown time. So this is what planned, in case of planned shutdown time, setup cost, setup of machine, time lost on setup of machine may come here. Time loss, you're losing the time to set up your machine will come here. So your plant operation time will include the time for the planned production time plus planned shutdown time. We always take some time to set up the machine. We will assume it here. That will be your planned shutdown. Planned shutdown. As next was what? Downtime due to machine failure. Okay. So downtime loss means due to machine failure. Machine failure. Right? So planned production time will be equal to what? Operation time or run time plus down setup time. Okay. Then what will happen? See, I hope it is clear. See, that first we consider this. Plant operation time which will be equal to what? Which will be equal to planned production time plus planned shutdown. Right? Planned shutdown. This is what planned operation time. After that, what do you have? After that, we have availability time. So here what will happen? Planned production time will be equal to what? Planned production time will be equal to availability time plus downtime. Abhi dekho, see what is happening, downtime. So in this formula, you are considering downtime. Downtime happened due to machine failure. So actually, sum of this value ka sum is equal to sum of these two values. If you add these two values, you will get planned production time. Okay. Similarly, when you add these two planned production time plus planned shutdown time, you will get plant operation time. You will get this. Okay, abhi we have learned only two type of failure. One is planned shutdown and one is unplanned shutdown. Planned shutdown happened due to you need time to set up the machine. Unplanned shutdown happened because of machine failure. Okay, this is what we have started up right now. Okay. Next is what? So next is what? Performance loss. Next topic is what? Performance loss. So how the company can have performance loss? Performance means how well you are performing. Now it is related to when you are actually working, when you are actually producing the goods, right? So it is something related to performance. So performance loss is related to speed loss also. This is also related to speed loss. Okay. So what is it? Small stop. And second is slow cycles. Okay. Now, small stop means what? Idling or minor stop. How this happen? So for example, the worker is working on machine. Obviously, he will take small breaks. Like for example, operator is working and he need time to eat, to have their lunch or breakfast, or tea break. So that will result in idling or minor stop. And reduce speed. Second is what? Reduce slow cycle, reduce steam. Maybe due to friction of machine, with time, the speed of the machine reduces. So that will result in what? Speed loss. So speed loss is one idling or minor stop. You cannot avoid it. Worker will take break. He will take tea break. He will take breakfast break. Worker when worker is actually producing the goods, he will definitely take breaks. That will result in what? Speed loss. And the second one is reduce speed means this cannot be avoided, but this you can avoid. What? Reduce in speed of the machine gradually with time. The speed or efficiency of the machine reduces, maybe due to friction between the machines, right? You can avoid it by greasing the machine or maintaining the machine, but again, it cannot be possible to eliminate them completely from the organization. Okay, so second is what here we are discussing: speed loss. The speed loss can be because of the break the worker takes or because of the speed loss with time of the machine. Okay. But remember, availability is actually equal to sum of these two values. Okay, so availability is actually equal to sum of these value, net operating time and speed loss. If you add these two value, it will become availability. Sorry, it will equal to operation or runtime. Okay, give me 1 minute. Let me explain again. So this will be equal to operation or runtime. Okay. Operation or runtime, this entire thing will be equal to sum of these two values. Okay. Okay, and plan production time is actually equal to sum of these two time, and plan operation time is equal to sum of these two. For that reason, I have written it in this way, right? And the last is net operating time is equal to sum of these values. Okay. Now the last one is quality loss, how the quality of the product can be lost. Okay. With the help of these three value, availability, time losses, performance, speed losses, quality loss, if you consider these three value, you will get OEE. Okay. So last is what? Quality loss. Let's see how we can calculate the quality loss. So in case of quality loss, you will check production reject and startup reject. So what is production reject or startup reject? This is what mistake, or you are producing defective units, right? So process defect means when you are producing the goods during the production, there is some defect. Generally, it is not possible if you have implemented lean system or just-in-time system. Process defect is will generally not happen, right? It is possible to remove them completely from the organization. Reduced yield means output is reduced. As expected, you are not receiving the output. So these two will result in what? Quality loss, right? Okay. So give me 1 minute. Let me write these formula again. Very important. You can see we have so many questions on these formula in the book. All right. After this, we will solve some questions. Okay. So you can see here we have taken some formula. What is it? We have taken here some formula here. We have taken some formula here, like you can see that how we can calculate the availability, how we can calculate the performance, and how we can calculate the quality, because when you multiply these three value, you will get OEE, right? So we will see how we find it. So first formula for availability is what? Runtime divided by planned production time. Planned production time, right? So you can see what is your planned production time. This is your planned production time. And in some question, you will see that you need to find the planned production time. So always remember that planned production time is actually planned production time is actually sum of what? It is actually sum of run time or production time plus downtime. Downtime can be of two reasons. No, downtime can be only one reason. The reason is what? When the machine will break down, right? When the machine will break down, the organization will have downtime. Okay. Due to breakdown of machine, the organization will have downtime. All right. The machine will have downtime if this is due to machine failure. Let me write it here. All right. So planned production time. is this. Next, availability. After availability, you have to calculate the performance, right? So performance is equal to what? Net operating time. Net operating time divided by runtime. Okay. So you know the runtime. What is runtime? Runtime is actually equal to net operating time plus speed loss. If you add them, it will become equal to runtime. Okay. Runtime. Or from the runtime, it is possible to find the net operating time. So you can see in numerator, we have net operating time. In denominator, we have the runtime. Okay. So always remember that runtime is actually sum of these two values. So runtime is equals to net operating time plus speed loss. Right. So in this way, we will calculate. The last one is good unit divided by total unit produced. So in last, you will see how much quantity we are losing, how many good unit we are producing, right? From the total unit, remove the defective unit, you will get the good unit divided by total unit. So in this way, we have these formula. Take a screenshot of this image because we will use it now to solve the questions. Right? I have list of questions. We will solve them. Take a screenshot of this. Yes, take a screenshot of this. This will be very helpful for you, right? This will be very helpful when you will solve the questions. So give me 1 minute. Let me take the question of OEE. We will solve all these questions today. This is the first question I have taken here, just in front of you. I hope the question is visible to all of you. The question is visible to all of you, right? So in this question, what do you have to calculate here? What do you have to do it here? So Kraft Indian Incorporation supplies the following information related to vital equipment used in the production activity for April 2018. What is given? Total time worked during the month is given. Total production during the month is given. Then number of unit accepted out of the total production is given. That means the difference is defect. So total good unit is given and the total production is given. Standard time for actual production is given and time lost during the month is given. What you have to do here, calculate the effectiveness of maintenance of the equipment. That means find OEE. Right? Read it. Read the question. All of you, please read it. Read this question. Yes. So OEE is related to availability. It is related to performance, and it is related to quality, right? So now you have to check that how you can solve it, right? Okay, so we have just done some formula. Give me 1 minute. Give me 1 minute. Okay, so if you will see, this is the question, this is the formula we have just studied, we have just discussed about availability. है ना? So what is the formula for availability? We consider the run time and the planned production time. है ना? You can see we have to consider, if you want to find availability, you have to consider the run time and you have to consider the planned production time, right? Okay, now the question comes here, ma'am, what is run time and what is planned production time? Okay, so what is run time here? So you have to see the downtime. है ना? Downtime means where you are losing the time because of machine failure. So from the planned production time, remove the downtime. Okay, okay, now let's see the question again. This is the question. Let's see the question here and see what type of time is given here. Total time worked during the month is given. Okay, standard time for actual production of the month is given. Time lost during the month is given. So time loss is given here. How much? 28 hours you are losing, right? So you are losing this time, right? This is what time loss, right? Okay. Now the question comes, let me write the formula here. Availability is equal to runtime divided by production time. Okay, I lost it. Give me 1 minute, huh? Let me take. Let me just copy this, huh? So runtime divided by planned production time. You have to find the planned production time here. Okay, so let me write the formula for you. This is the formula, right? So you have to consider what runtime and you have to consider the planned production time. And you know that planned production time is equal to runtime and time loss. We have learned this, that planned production time is equal to runtime plus time loss. Now see here, time loss is given. Okay. Now see here, what will be the runtime? Runtime is also known as what? Runtime is also known as what? We have learned it here. What is the other name of runtime? Operation time, right? So you will see the operation time here. Give me 1 minute. So you will see here the operation time, that how much time it is taking to operate this, right? Okay. Okay, so the total time to work during I mean, the run time during here is 210 and the downtime is what? 28. Operation time is what? Total time work during the month is what? Run time or operation time. Total time to work. Okay. Operation time. This is what. So you just put this value and solve and tell me what is the value of availability coming here. Right? You will get availability here. Check and tell me what is the availability coming here. Now the next, after finding this value, you have to find what? Performance. Let's see how we will calculate the performance. So performance is what? Performance is related to what? Net operating time minus any divided by runtime. Ab dekho, runtime is this, right? So 210 is the runtime. Net operating time means what? See the graph again, see the picture again, net operating time. So you can see I have mentioned here what is the net operating time. So net, in case of net operating time, reduce the speed loss from the runtime. If you will reduce the speed loss from the runtime, you will get net operating time or the actual time for which you have work. So see the question whether the actual time is given or not. If not given, then from the runtime you have to remove the speed loss. Then you will get the actual time, or otherwise in the question the actual time should be given. So you have to check that whether actually this is what actually time for which you have worked, right? And run time means for how much time you have done, and this is what speed loss or time loss due to failure of machine or any other reason. This is what time loss, that will be equal to planned production time. All right. Okay. So just come back here and see what is your actual time for which you have worked. So this standard time for actual production work here is what? 180. Right? Standard time for actual production is here 180. Right? This will give you performance. Always remember this value is coming less here because speed loss, because of speed loss. Then total time you were expecting it will take 210, but there is some loss due to downtime, time loss, right? Here the time loss is considered, right? So for that reason it is coming here. So you will calculate the performance here. And the last one is quality. The last one is quality. So for quality, you will see the number of good unit we are producing. We are producing 2520 good unit out of the total 2800 units. Just solve them, you will get the answer. Solve these three values. Solve the first one, and then solve the second one, then solve the third one. Solve them and get the answer. Solve them, you will get OEE. Solve these three values, you will get the answer. If you want, I can help you in solving it, but I need a calculator. So this will be what? 210 availability. This ratio later 210 divided by 238. 238. This will give you what? 88.23%. So this is coming as 88.23%. All right, let's see this one. 180 divided by 210. 180 divided by 210. So this is coming as 85.71%. 85.71%. Now let's see for the quality, what is it coming? Be what? 2520 है ना? Divide it with 2800. 2800. What is it coming? 90%. Huh? Now just do one thing. Multiply these three values to get OEE. Okay. Multiply these values. You have to just multiply them. 88.23% into 85.71% into 90%. Multiply these values. Just multiply these values, you will get the answer 90%. Right? Multiply these three values. So where is my calculator? We will consider 88.23 into 85.71 into 90. Right? Divide it with what? 10,000. You will get 68 point. Efficiency will be coming as 68.06%. I've just rounded the values. So this will be the answer. Okay. So here overall equipment efficiency is coming here for this is 68.06. Now the question is that we have already discussed that 100% overall effective efficiency is not possible to achieve for a reason. Let me explain you the reason why it is not possible. Because not at all possible. It is never possible that you do not allow break to your employee. And you will say, nay, if you are coming for 9 hours, you have to work for 9 hours. This is never possible. You will give them break. Machine will gradually have the frictions and speed of machine will gradually reduce. So there will always be some speed of loss. Speed of loss will always be there. It cannot be eliminated 100% no matter how good your organization is. It is never possible to eliminate them 100% from the organization. Some time loss will always be happen. Shutdown or machine failure type of losses, to some extent it will always happen. It is not possible to remove them 100% from the organization. Sometime your machine will fail for, even for, you can say 15 minutes, but this will happen. Not possible to eliminate them 100%. So you will see, I have a PPT. Give me 1 minute. You will see there that it will never be 100% for any organization. So OEE, according to OEE, world-class performance, the best performing organization can achieve max to max 85% of OEE. They cannot achieve more than 85% of AEE. So this is the max OEE that can be achieved. That means I hope you can understand these losses are not possible to eliminate 100% from the organization, no matter how good organization is. No matter, doesn't matter how good organization is working, it hardly matters. It is not possible to remove them 100% from the organization. You cannot say that the organization is working 100% effectively and there is no such losses. That is not at all possible. Not at all possible. All right. Okay. I hope it is clear. Let's take one more question. We have half an hour more. I don't want to start a new topic. We can cover this topic in next session, right? So we will study about the Six Sigma. This is all about Six Sigma. Then we will study about the total productive maintenance. Total quality management. You will study about it. And then we will study about the process innovation. And then we will study about business process re-engineering, right? We will study about all these topics in next session. Okay, we have one more session for this topic. So I'll be taking these topic in next session. Right now, let's do some more numerical questions. Some questions. Let's do some more questions. All right, let's do some more questions on these topic. So we are here learning more question on OEE. ठीक है. अच्छा, before that, let me tell you again one more point which I want to explain. I just forgot. Give me 1 minute. So if you will see, the next topic is on Six Sigma. है ना? Six Sigma. है ना? But before introduction of Six Sigma, we have already learned some topic. What are these topics which we have already learned? First topic, we have already learned about the lean management, or just-in-time system, which is also known as Toyota production system. We have already learned it. Second, you can see the most important topic, total productive maintenance, we have learned. And you know what? These two beautiful business strategies, I will say beautiful, they are beautiful business strategies, right? They were all introduced in Toyota company, right? Toyota company. And actually, it was all happened because of W. Edward Deming and Joseph M. Juran. W. Edward Deming 14 principle. You can see in Toyota production system, just in time system, they have adopted all the 14 Deming principle. Now the point is that why I'm discussing the same thing again and again, ma'am. So why are we discussing this? Because this is all happened in Japan. And all these things brought revolution in Japan. Japan was known for quality product, and it's all implemented in electronic company and automobile company of Japan. So if I was a child, I have heard this from the childhood that the Japanese product are quality products. Japanese are known for producing quality product right the first time. They're always, quality product. They always produce a quality product. But the point is that after World War, Japan was completely destructed, and then within few years, they have created world's third largest economy. They have produced such a quality product that they start becoming threat for US company, right? Such a, revolutionary product they start preparing. They become a threat for US company. And in response to all these strategies, lean management, total productive maintenance, to respond these strategies, they have introduced a Six Sigma. All right. So Six Sigma is birth of, actually a response of, all these business strategies. And it all happened in Motorola company. So if you will see, Six Sigma was all introduced first time in Motorola company after the revolution happened in Japan. Okay. So this is something I have repeated again. I don't know how many times I'm repeating the same thing, but the point is that this will help you to clear your concepts. Okay, now let's do some more question. Let's do 1 or 2 more question on OEE here. All right. See, what I will advise you people, take a screenshot of this. This will help you a lot when you will solve the question. Take a screenshot of this. This will help you a lot when you will solve the questions. Right? This will be very helpful for you when you will solve the questions. Take a screenshot of this. All right, take a screenshot of this. Okay. Because you can see here, with the help of this diagram, you can easily relate what you have the runtime here, and we are using the runtime here. Then we have what we have planned production time here, and we are using the planned production time here. And when we are dividing these two value, we are getting what? Availability. Similarly, if you will see here, we have what? Net operating time. And when we divide the net operating time with the run time, you will get performance. So for that reason, better you write it somewhere. It will help you a lot later on. This will help you a lot later on. Okay. So run time divided by planned production time, you will get availability, and net operating time divided by run time, you will get performance. Okay. And why the difference is coming, keep it in mind. First is time loss. And the second one is speed loss. So because of these two losses, this difference in time is coming here. Okay. Planned production time, run time, the difference is time loss, and net operating time and run time, the difference is speed loss. Just remember them. Whatever the question they will ask you, you can answer them very easily, and you will find them very easy to answer. You will find them very easy to answer. Okay, so let's take one more question. A very good, interesting question. Let's do this question. Again, this is a question on OEE. We have to find OEE here. We have to find OEE here, and we have to calculate the value, and then we have to comment on it. Okay, so we know that OEE is equal to availability, right? Availability into performance into what? Quality. We know it is equal to this, right? Now the point is that availability means it is actually a formula of what? Runtime divided by total production time. Runtime divided by planned production time. All right. Okay, I lost it. Okay, give me 1 minute. So, planned production time. Runtime divided by planned production time. Right? Then planned production time. Then performance is equal to what? It is equal to what? Runtime is in denominator. And what do you have? Your net operating time. Net operating time divided by runtime. You have to learn it, right? Net operating time. You have to learn it, and you have to, you have to practice to find these values. Okay, if you will see, I need actually 3 values. One, I want to know what is the runtime. Then I want to know that what is, give me 1 minute. I want to find 3 values here. One, I want to know what is the total planned productive time. Right? Then I want to know runtime. And the difference between them is time loss. Then third, I want to know about net operating time. And the difference between them is what? The difference between them is what? Time loss. This is what? Speed loss. Right? Okay. Now the point is that let's read the question and let's try to solve it. What is the question? Read it. I'll give you first 2-3 minutes. Take your time and read it. I'll give you time to read it. Read this question. Read this question. Yes, read it. Take your time to read the question. Okay, so what is happening? PK Pharmaceutical Limited is producing medication products like pills and balms, etc., and can be called as a high volume based production environment. There are several different automated production machines located in plant through which production of machines is accomplished and fulfill the demands. Plant operates in double shift a day, each consisting of 8 hours with 30 minutes lunch break and tea break of 15 minutes. Right? So you can see here, they have a lunch break and they have a tea break, right? And for how many times the worker are working here? They are working here for 8 hours. Hai na? And what else we have? We have breakdown or repair or startup time is what? 68 minutes. And what we have? Standard cycle time is what? 2.5 minutes per table. And try to solve it at your own. Okay, I'll give you time. Take your time and solve it. Try to solve it. Take your time, solve it, and then I'll help you. Yes, please solve it and tell me how we will solve this question. So here, I hope you have tried this question. So here, what we have to do, we have to first find what the run time and the total time for the production. So if you will see here, run time means what? Total time for the production minus if there is any time loss, if you're losing the time. So if you will see in time loss, we were considering both time taken to set up the machines and the break of the employee take the tea break, employee take various break. So time loss will include all those losses, right? Time loss will include everything, all the losses that happen. So if you will see here, what is happening here? So what is happening here? The worker is actually taking how many time? 30 minutes of lunch break, 15 minutes of tea break. This is what? The time lost by the worker. And what I and see we have planned downtime and unplanned downtime. So you can see this is also a downtime. This is also time loss, right? So you can see 30 minutes is a time loss, 15 minutes is a time loss, and 68 minutes is a time loss. So see what is the sum of these losses. All right, let me write it there. Time loss is what? 30 minutes plus 15 minutes is a time loss. Then 68 minutes is a time loss, right? These are all time loss. Just find the sum of these value. 30 plus 15, 45 plus 68. Okay. So this will be coming as 113 is the time loss. Right? You will consider this as a time loss. All right. Then you have to check the plant production time. It is coming as Acha, one thing we have to check here. What Acha, one thing we have to check here. Give me 1 minute. Let me write it somewhere. So in one shift, in case of one shift, the worker is having these losses, right? 30-minute loss and 15-minute loss, lunch break and tea break. It is in one shift. And here the worker is having two shifts, right? In one shift, this is the loss, right? But if you will see, this is what downtime during the entire shift. One day, the worker is having two shifts. You know? In one day, there is two shifts. So this is the loss in two shifts. You know? This is the loss in two shifts. What 68-minute loss is in two shifts. All right, this is what a loss in two shifts. So in one shift, you have to divide it, right? 68 divided by 2. What is it coming? 68 divided by 2. It is coming as 34 minutes, right? Now check what is the sum. 45 plus 34, 79. 79 minutes is the downtime here. So this will not be 68 here. It will be what? Half, because number of shift is given here, right? So this will be 34 minutes. All right. Okay. Give me 1 minute. Okay. Now what else is given here? It is given that the worker is working 8 hours, right? Worker is working total time, we will find he is working 8 hours. Okay, here the total time will be coming as 480, by the way. All right, 480 minus, what is it? Okay, give me 1 minute. This is your 45 plus 34. So this is coming as 79. Now, let me write it here. So your time here will be what? 79 hours. You know? So in this way, you can tell about what? Availability, right? You will get availability. What is it coming? Solve it and tell me what is it coming. Solve this and tell me what is it coming. Okay, I'm just solving it, huh? So this is coming as okay, 1 minute. I want to explain some more point here. So here, what will happen? We have to consider the run time and we have to consider the planned production time, right? If you will see that image, okay, it's a good question, by the way. If you will see that image, give me 1 minute, huh? So if you see this image, we have learned about what the losses, right? Okay, give me 1 minute. So if you will see here, we have two type of time loss. One is loss due to lunch break, right? And one is the loss due to what? The other reason, that was breakdown. So you can see here, downtime is what? Breakdown of machine was 35 minutes, right? And lunch time was 38 minutes. What was that? Okay, here. So you can see here, you have what? Breakdown loss is what? 34 minutes. Okay, half of this value. And the loss due to lunch break or loss due to lunch break or tea break is 45 minutes. Acha, come here, because see, it will be easy for you to understand it in this way. Or let me do one thing. Let me just take a copy of this, so that it will be easy for you to understand it, right? I'm just taking, give me 1 minute. Okay, so let me take this here so that it will be easy for you to understand. Okay. So if you will see here, we have what? 35 minutes as what? This is loss of time due to machine failure. And 34, not 35, this is 34. Half of 68 is 34 is the time loss due to machine failure. And planned time means lunch break and breaks of the employee. So we have 45-minute time loss due to break of the employee, right? So these two losses is given here. All right. Now we have to find out availability, right? So we have to find availability here. How we can find the availability? So we know the total time here is what? Total time for which the labor will work was 48 hour, 480 hour, right? 480 hour is the total time for which the worker will work. All right. This is the total time for which the worker will be working, right? Now, out of this, you can see 480 is the time for which the worker is working. Now, when you want to find out the availability, in numerator, we have to consider the run time, and in denominator, we have to consider the planned production time, right? Now, the point is that if you want to find out the planned production time, what you have to do, you have to consider this total time minus this planned shutdown time. So you have to consider the total time minus 45, right? In denominator, we consider the planned production time, right? So how will you get the planned production time? Total time minus planned shutdown time, right? So in denominator, we will consider planned production time, which is this. And in numerator, we consider the run time, right? Run time is what? Run time will be planned production time minus downtime. So what is your planned production time? This is your planned production time. This is your planned production time minus this downtime loss, which is 30. So we will subtract these two values to get our availability, right? This is how we have to do it here. right? If you will solve it now, you will get the right answer. Okay. Okay. Let me do it. 79. So 480 minus 79. This will be 401. Right? Divide by 480 minus 45. Minus 45. This will give you what? 435. Huh? Now divide them. 401 divided by 435. 401 divided with 435. This will be giving you 92.18%. 92.1. Okay. So availability will come this value, right? Okay. So this will be the availability. Now we have to calculate performance. Now performance is what? Performance is equal to runtime. In denominator, we will take runtime now. So runtime is this now. You can see this is your runtime. So 401 is your runtime. Now see what is your net operating time. Net operating time divided by runtime will be your performance. Net operating time. Okay, let's see now how we will find it. So this is given here that standard time for the production of one tablet is 2.5. How many units we are producing, right? Let's see how many units we are producing here. So the point is that total quantity is expected to produce this, but out of this 50 unit will be defect. So how many units, good units we are producing? 230 will be the good units which we are producing. No? These are the goods which we are good unit which we are producing, and for one unit we are taking 2.5 minutes. So what will be the standard time is required here? 230. Okay. Solve this. Okay, give me 1 minute. I'm just solving it. Give me 1 minute, I think. Asha, yes, one thing we have to consider here, that this is the production during 2 shift. This is the production of 2 shift. Okay, so this is the defect of 2 shift. These are the units which we are producing in 2 shift. So just divide it with 2 so that you can get the production in 1 shift. All right, divide it with 2 to get the production in 1 shift. This is what the unit which we are, good units we are producing. These are what good unit we are producing in 2 shift. So divided with 2 to get the units which we will produce in 1 shift. So 230 divided by 2 into 2.5. Solve this. Let's do this. $230 divided by 2 into 2.5 divided by total good unit was your runtime. So 401. Solve it and you will get the answer. $230 divided by 2. 115 into 2.5. This will be 287 divided with 401. 71.69%. Right. Next is what? Your quality. ठीक है. So quality means what? You will check the good quality and then you will check the total quantity. Good quality product and total quantity you are producing. Now, if you will see here, the total quantity is what? 280 tablets. Here we are producing how many tablets? 280 tablets are the total units which we are producing here. Okay. So total good unit which we are producing here is 280. Good quality product is this, you know, 230. Right, these are in one shift. 8 minutes. Yes, they are in two shift. Okay, divided with 2. So you can divide both the value with 2. You will get quality ratio. So what is it coming? 230 divided by 280. This will give you 82.14%. Right. So in this way, you will calculate these three ratio. Okay. Availability is OEE. Now let's calculate OEE. So availability is coming as 92.18%. Performance is coming as 71.69%. This is a good question, by the way. They have given you so many information here. And right, just multiply it, you will get OEE. Right. So this is how we have to do. Keep it in mind in this question. They have actually given you 2 shift. So the point is that these information, these good units are for 2 shift, right? This information is 2 shift. These information is all for 2 shift. And here 30 minutes lunch break and tea break is for 1 shift. You know, so you have to keep it in mind. Then only your answer will come correct. Otherwise the answer may be wrong. You know? Okay. So this is how, and always remember when you're solving this question, just consider this. This will help you to solve and understand the question. Actually, it will be very easy for you to understand the question. Since here, if you will see, when we want to find out the availability, we have to consider the runtime divided by planned production time. In this question, they have not given you this information. They have given you total time. So from the total time and removing the planned shutdown time, you can find the planned production time. So in this way, you can see they can give you any information and they can ask you any question. So it's better if you learn this chart. It will help you to solve these questions very easily. It will be very helpful for you, right? And now if you have doubt, you can ask me. I'm just looking at your doubt. And if you have doubt, you can ask me. Otherwise, I'll wind up the session. Very nice. You people are solving, huh? Why we take 230? Why not? What is there any doubt now? I think it's all clear. Say yes or no. Write in comment quickly. If you have any doubt, please write in comment quickly. Otherwise, I'll be winding the session. Is there any doubt now? 35. That was by mistake. I was assuming different figure. For that reason, I've taken 35. It is 34. No? So for that reason, I've taken in one page so that I can remember that what number we have to consider, what figure we have to consider. Right. Okay. So I don't think that you have any doubt here. But yes, just remember, dear, one thing. If you will learn this table now, it will be very easy for you to solve the question. So just learn these table, these values. It will be easy for you to solve the question then. All right. That's it. Shall I wind up now? Okay. So take care, all of you. Have a nice day. Have a nice day to all of you. Take care. Bye.